Hello everyone, sorry for the bad scheduling. I forgot to schedule the stream actually on time, so um, thanks for showing up anyway. Just getting everything in place, and we should be coding in a second now. Okay, so I think we have everything in place. Before we start coding anything, I want to clarify one thing. I want to clarify basically what are we going to be doing today. So let me just make the camera a little bigger. Yeah. So okay. So sorry, I don't have a whiteboard or anything to explain this in a better way. We have an environment in here, and we have an agent. So the way this works, actually, the environment will produce something to the agent. What the environment will produce to the agent is a state. Let's just put letter S in here. So it will produce a state to the agent. The agent has a number of actions that it can do based on the current state of the environment. Try to center it. So it can produce some kind of action based on the state of the environment. So the agent will produce actually an action. Let's denote that with an A. And that action returns something to the agent. It returns a reward. This reward can be a positive reward, a negative reward, high reward, low reward, it doesn't matter. But it produces a reward. Then the cycle repeats again. The environment produces another state, the agent produces another action, the environment changes a little bit and produces a reward back to the agent. And the cycle keeps going. So let's start coding this. I will be coding this in a way that makes it a library, actually. So I'm not building an application now. We're building a library that does this. Okay. So I'll go in here. I'll go to my Golang directories, RC, GitHub, twisted hardware, and mkdir. I will just call it. I'll just call it QL for Q learning. CD QL. Okay, so I can do vim, and let's start working on the environment. Environment.go. I hope I did not misspell environment. That would be just me. Okay, I'll call the package QL, and let's start building this environment thing. So the environment, I will build it as a struct, basically. Type, just call it env, because we're going to be using that a lot. So I'll just call it env for now, and struct. So what variables will go inside the environment struct is variables that will start building as we go. I intentionally don't prepare for these to make sure you get the raw thing as much as possible, to get my train of thoughts. How did I get to anything I'm doing in here? So back to our amazing illustration in here. We had the environment. The environment can produce a state, and it returns a reward and receives an action. So let's make these into methods of the environment. So we'll do func e pointer to env, and I will call get get state, maybe get state. So get state will return a state of the environment. I guess we have to the state is the state basically describes the environment. This state can be a number of things, but we will make it into an array of bytes, maybe, or integers. I guess we can just make it an array of int. So it will return an array of integers, which describes the environment. For now, I'm just trying to get all the functions, the methods out of the way. We'll make these methods do things as we write more code in here. So func something else. I will do e pointer to env. Then I will do something called action. Maybe get actions, actually, because I want to get what actions can I do at this stage in my environment. Maybe I cannot turn left because there is a wall there, or I cannot do this action because of how what's my current state inside the environment. So I want to get another method called get actions, and get actions will return back to me also an array of integers, which are basically the a list of actions. It will just tell me you can do action 1, 2, and 3, for example, or 1, 2, and 4. So I know I can do these 3 actions at this stage. I can, after getting the state and after getting the possible actions, I will do another function now, or a method to this struct env, and I will call this one action. So this one actually will produce, this one will actually perform an action. So this receives this will receive a parameter, which is the action that we want to perform on the environment. When we perform an action, the action will actually return back a reward. So the reward will be a float 64, which is like a decimal number. And I think we have everything we need now for our environment. So I will save that. Oh, actually I don't have a return in here, so it's complaining about that. I'll do return. Let me initialize it first. I will do something like slist equals int and return slist. And again in here, a list is also an array of integer, and I will return it. Return a list, and finally in here I will call r my reward 0.0 and return are my reward. See, okay, looks good. The next thing that we want to start working on is the agent. So I will do vim agent dot go, and I will build this quickly. Type agent struct. Let's not put anything inside the agent for now. Let's just do the actions that the agent can produce. So the agent receives a state from the environment, and it produces an action based on that state. So I will actually I can make it into a single function, I guess. If we need more, we can add more later. Agent, and I will call it choose action. Choose action. And choose action receives actually an array of integer, which is the list, which is basically the state. So let's just call it state for now. State. So it receives a state and it returns an action, which is an integer in here. Let's do this quickly, where we do a, or let's just call it action. Action is 0 for now, and return action. Okay, most environments are the state in the environment is something that the environment should keep actually inside itself. So I will make this into a private member of the environment. I will call it I don't know, I'll just call it state, which is list of integers, and I need to keep a counter of how many steps have passed since we started this process of interacting with the environment. So I'll call it step, which is an integer also, and let's save that for now. So right now we have an environment and we have an agent, and the agent can the environment can produce we can get the state of the environment, we can get the possible actions that we can perform on the environment, and we can perform an action also on the environment. So these methods are going to be application specific. So if I was building an environment to play like a maze game, the get state is going to return a description of the maze and where is the player inside the maze. Get actions is going to give me which actions can I do, right, left, up, down, and action will actually move the player into that position. So the environment we're building now is actually we're building it for as a robot that can trade stocks. So our state and step are going to our step is going to resemble some kind of a date time to show us where are we in our date time basically. So 0 will be the first step in our simulation, and our state will be it will be few things. It could resemble maybe the price of the stock, some indicators, or anything that we want to make our environment do. For now, just to do like the most simple thing, solving XOR. solving an exclusive or problem is one of like the simplest things you can do with reinforcement learning. So we're gonna build an environment that does specifically that for now, just to get our hands dirty with something that actually works. So just a quick reminder of exclusive OR gate. Let me just put my camera, it's a larger thing in here. So an exclusive OR gate looks like this. 0 0 0 1 1 0 1 1, and the output of these 0 0 gives a 0, this gives a 1, this gives a 1, and the last one gives again a 0. So, and this is XOR. So we want to solve XOR, which is a really simple thing, and reinforcement learning can be like overkill for this, but it's a good way to get ourselves familiar with what we can do with this. So what our state is going to be one of these. Okay, our actions can be either 0 or 1, and the reward is going to be the absolute distance between actually we can make our reward 1 if we get it right and 0 if we get it wrong. So something simple. So let's do that. So this environment get state, our states in here are going to be actually let me encode something. Let me do something in here. I will create a constant, const I guess you don't have to do that. I guess I can do this, where I can const, I guess I could encode all of my states, or I could call it a state list. State list equals, and const, yeah. It will be an array of it's an array of int actually. Okay, and inside this array of int I will have an array of int that has the following. It has 0 and 0. Array of int. Why is it not happy with it? Oh, it is happy with it. Equals an array of int, and inside that I have an array of int. Okay, that makes sense. It's kind of unhappy with something we did here. Let's just try to do this. Let me just increase the font in here. Oh, actually I was doing something really horrible in here. I was writing all of that code when you were looking at my face instead of the code, which is really fun. You just like it when that happens. Anyway, where is my code? Okay, so I did this. I did a constant in here that has, which is an array of int, and inside it has bunch of arrays of ints, which are my states. And it's saying that it's unhappy with what we did, so I'll go in here and do go build, and it's saying initializer. Okay, it's unhappy with that. Okay, let's change this. List equals, I guess if it's maybe a var, it will be happier. Var equals state list, and I'll go here and try to build it again. Okay, it likes our code now. Okay, so our state list will have a bunch of states. So 0, 0. This mosquito is really happy with me. Anyway, 0, 1, exactly the list we had in there, and 1, 0, and finally we have int 1, 1. Let's save that, and we have our basically our answer to this list. I will call it I'll just call it answer for now. Var answer, and answer equals an array of int, which will be 0, 1, 1, and 0, which is the answer to this. So the first item in here is the answer to this. So 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, and 1 XOR 1 is 0. So this is the answer to this, basically. So in here, get state, instead of doing that, it will just pick randomly one of these. I guess I could make it randomly, or I could keep, or I could just feed it back to the agent one by one. So feed the first one, the second one, third one, fourth one, then again first one, second one, third one, fourth one, and just keep repeating that. So this is, I guess this is the easiest way to do it. So my S list will be, it will go to state list, and I want E, so my environment dot step modulus 4. What does that do? Okay, let me explain this quickly. Modulus 4, so 0 modulus 4, let me do this in here quickly so you can get a better sense of what's so I'm doing this in Python quickly. So 0 modulus 4 is 0, 1 modulus 4 1, 2 modulus 4 is 2, 3 modulus 4 is 3, 4 modulus 4 is again 0, 5 modulus 4 is 1. So I will just keep getting this pattern 0, 1, 2, 3, 0, 1, 2, 3 over and over as my step increases. So basically I'm getting one of these, and it will just keep repeating, and I will return it. Get actions, it will just return these two actions, 0 and 1. These are my possible actions. And action will compare, it will check if we get the right answer or the wrong answer. So what I will do in here, I will check if we get the wrong answer, or the right answer or the wrong answer. So how can we do that? I'm getting an A, which is my action, and I know the step we're in, so I know which question we're trying to solve, which state we're trying to solve. So I can do E dot step. I guess I can just do this. State list of E dot step modulus 4. No, but this is the state. I don't want the state. Actually, I want to check which action. So I can do answer of E dot step modulus 4. Now I know the right answer, and I can compare this answer to the action that I received. So I can do actually I can do it like this. R equals the correct answer minus the action you gave me. Then I'll get the absolute value of this. So let me import math quickly. I will import math, import math. Then I will do, actually I will do this in here. I'll delete this line and I will make this, I can do it in 2 lines to make it even clearer. R equals math.abs of R of, okay. R is already declared as an integer in here because it's subtracting 2 integers, and math.abs actually does not return an integer. Let me show you. Actually, this thing returns, yeah, if we check, oops, yeah, if we check in here, ABS, it takes a float 64 and returns a float 64. So I have to make this as a float 64 to begin with. So I'll have to take these 2 numbers and then float 64 of this thing, then take the absolute value of that and make it into an R. Then return that back into an integer before we return it back to the, So I have my correct answer minus the answer that the agent gave me, and I'm taking the absolute value. So if my answer was 0 and I get a 0, it will just be a 0. Absolute value of a 0 is 0. If my answer was 1 and I get a 0, it will be 1 minus 0, which is 1. So my absolute value is 1. This actually will give me 1. This is not a reward anymore. This is more of an error. So if I want to make this into a reward, I have to put a minus in here. Okay, I'll just do this. Oops. I'll put a minus in here, so I will always have the negative of int of R. Why it's unhappy with int of R? Wait. I guess I can do this. Then I can multiply this by minus 1. Doesn't matter. It's really unhappy with it. Oh, because my reward is actually a float 64, so I really don't have to do that. I don't have to make it into an integer. Even better. Okay, so now we have an environment for XOR that can basically solve XOR. And now we can go to our agent and have our agent know how to solve this thing. So my agent in here my agent in here has this. I will add to my agent like a policy, basically a policy. So this policy is a map of an array of integers. I guess I can make it an array of 2 integers, so it's an array, it's not a slice. So it takes 2 integers as a key and it returns 1 integer as, I guess I can make that into a float, then convert that into something else. So when I say choose action, I will do something like this. If a dot policy equals null, so if it's not initialized yet, then initialize it. Then a dot policy equals this thing and initialize it. Then I will do another if in here. If a dot policy of, I guess I could cast, I could cast it, but I would rather do this quickly in here. S equals to end, to end, so an array of 2 where the two values are state of 0 and state of 1. So now I have my state in a format that works with my policy. So I can do if policy of S, which is an array of length 2. Okay, I guess I could do this. If it's already there, if I have a policy, for this one, then we're fine. The problem is if we don't have a policy. So if not okay, if you don't have a policy for this state, this is the first time you see this state, then initialize this state. So a dot policy of S equals 0.5, because right now I don't have really a policy for it. I don't know if it should be a 1 or a 0, so just initialize it with something in the middle with 0.5. Then the action that we want to take is basically the best action that we this is the policy, and it should be map of these two, and it will give me yeah, okay, that's fine actually. If I did it this way, I have only one value for both 0 and 1. I want to do actually 3 things. I want to get my state and know which action, and each one of these should have a policy, an expected reward for that answer. So I guess I could do one more thing in here where my policy is actually of length 3. So the first 2 are my 0, 0, 0, 1, the state, and the last part is the answer that we want to give. No, actually, I think I have a better way to do it. Sorry. I know I'm going all over the place in here, but I'm just trying to make it into the into an optimized thing, and this is how usually any developer would work when they're thinking about something new that they're building. So just bear with me in here. I know we're already over our 30 minutes marker, but I'll try to close this quickly. So I'm initializing it. I'm initializing it basically as the value that we should give out. So choose action, then I can, I guess I can keep track of which environment I'm in. So E is EMV, so I can get to the environment that I'm working with. I'll make it a pointer to the environment. Then I can, after I chose the action that I want to do, I can tell the agent maybe I will import math in here, and I will try to round the number. So math, import math, and I will go math dot round. I will round the policy. I will round the policy, and this will be the action that I will be taking. So what does round returns? Round returns a float 64, so I will return that. So I will do action equals integer of this thing. Okay, then now I know which action I took, so now I can go in here and I do a dot emv or e dot where is perform action? It's just called action. So I will pass the action that I decided to do, and I will get my reward now. So R equals the reward that I'm getting for the action. Now I can use that reward to update my policy. So if I'm getting a negative number, I can update my policy to do something different than what it did last time. If I get a positive reward, I will enforce my policy to repeat the same action next time, because it was an action that gave me some positive reward. And I will actually stop in here right now. I'm already 4 minutes over my 30 minutes broadcast. I hope that was insightful. I hope that was useful for you. I hope it was fun, and we'll pick it up from here again tomorrow. I will be tomorrow we'll be taking that part, and we'll be doing the update to our policy. We'll be learning tomorrow about something called the learning rate, which is the alpha. So how fast do we want to change our policy based on feedback from the environment, and how fast your policy will converge into doing choosing an action based on these rewards. Anyway, if you have any questions, you can find me on Twitter. I'm there basically, and you can easily reach me there. Anyway guys, leave a comment if you have any feedback, and I would love to hear from you guys. Thank you.